Okay, so the purpose of this video is going to be to go from our definition of a limit from last time and a couple of examples to some template examples. Template examples. Okay, so let's take a look at our first one. Maybe the limit as x goes to 0 of 1 over x. Just to be more, well, we can go from both directions, but let's go from the right first. What's happening there? Well, as x approaches 0 from the right, that means we're taking things like x equals 1/10, x equals 1 over 100, x equals 1 over 1,000, right? And so what will our f of x be? F of x will be 1 over 1/10. Do you remember how to compute that? So if you have a fraction divided by a fraction, you invert and multiply. So that's a over b times d over c. Right, so in this case, this is going to be 1 times 10 over 1. And so this is going to be 10. So then if I plug in 1 over 100, 1 over 1 over 100 will be 100. Okay, I think we can see what's happening now. 1 over 1,000, the y value is going to be 1,000. So it looks like as x approaches 0 from the right, the y values are getting larger and larger. Oops, larger. Good. And so in order to abbreviate this, we're going to say that the y values, oops, I'm trying to get my hands more comfortable here. Y goes to infinity. Right? These y's never stop as x gets closer and closer and closer. The y values never stop, and so they go to infinity. And so we use our infinity symbol, y goes to infinity. Okay, so what does this mean? This means that y keeps increasing larger and larger and larger, more than any positive number. Okay, so as x goes to 0 from the right, we see that y goes to infinity. Now what we could write is this is equal to infinity. I don't really like to do that. The book does this. And the reason I don't is because we might say, well, infinity is not really a number. Remember what we were talking about with our limit? So I would actually say that the limit in this case, the limit does not exist because the values go to infinity. So in this case, we're being very specific, right? Our book will actually use infinity like a number in this case, but I don't really like to do that. All right. So similarly, what happens as we go to 0 from the left? Well, in that case, the x values, as they move closer and closer to 0, they would be numbers like minus 1 over 10, minus 1 over 100, minus 1 over 1,000. And so we've already done that computation, right? That's going to be minus 10, minus 100, minus 1,000. And so here we would say that the limit goes to negative infinity. Okay, good. And so actually this is going to be the case. This occurs, this happens whenever we have a fraction of the form where the numerator is a constant that's not equal to 0 divided by something going to 0. Goes to 0. Okay, so if you have a fraction where the numerator is a constant that's not equal to 0 and a denominator that goes to 0, you may conclude that overall the limit does not exist. Overall limit does not exist because the y values, you can just say it, goes to plus or minus infinity. So we could be more specific. It depends on which direction we're going to 0. Okay, but overall then we can just say that the limit does not exist. By the way, this also means that there's a vertical asymptote, right, for the function vertical asymptote. Good. All right, so this is what it means to have the y values going to infinity, plus or minus infinity. We have a vertical asymptote. Oh, have we defined what a vertical asymptote is? Maybe I should be careful about that. Let's be sure and define that. Vertical asymptote, just to be sure we've got that in our pre-calc toolbox. So if I have my function, then what makes this a vertical asymptote is that the function must blow up here at some point, either going this direction, or it has to go that direction, or it has to go that direction, or it has to go that direction. One of the 4 things must be true. Okay, and so we can abbreviate that by saying the line x equals a is a vertical asymptote if one of the following limits is true. And that is the limit as x approaches a from either the right or the left. See how I'm pronouncing this? This is the limit as x approaches a from the right or the left of f of x is equal to plus or minus infinity. Okay, so notice that this is actually 4 statements, right? This says the limit as x approaches a from the right is equal to plus infinity, or the limit as x approaches a from the right of f of x equals, or maybe better be explicit here, this is an or there, minus infinity, or the other 2 cases. Okay, and so that's what we mean by a vertical asymptote. So a couple of special notes for vertical asymptotes, and that is y equals the tangent of x has vertical asymptotes. Do you remember where? The graph looks like that. In fact, it has vertical asymptotes wherever the cosine function is equal to 0, which will be pi over 2 minus pi over 2, and then it has the tangent function has period pi, so this is going to be 3 pi over 2, and so on. Okay, so the vertical asymptotes for the tangent, the primary ones we're concerned about usually are plus or minus pi over 2, but any odd multiple of pi over 2 will also have one. The other one that people may forget is that the natural log has a vertical asymptote at x equals 0, vertical asymptote at x equals 0, and that's because, do you remember what the graph looks like? Sure, it looks, whoops, it looks like that. That's not supposed to intersect, that goes to minus infinity here. Okay, and then it goes up like that. And there is no horizontal asymptote either, right? This just keeps on going up and up and up and up and up. Good. Okay, so those are our 2 special cases. Tangent and natural log. People tend to forget that those have vertical asymptotes. Good. Now, one other thing I wanted to talk about was a horizontal asymptote. How do we get a horizontal asymptote? Well, horizontal asymptote looks like the following. If your x, as your x gets very, very large, it means that your y values are settling into some L. So this means, so your function is doing something in here that could be real wild, but as x gets large, right, your y values are starting to settle in to a value very, very close to L and converges to L. Okay, so this is what it means to have a horizontal asymptote. So y equals L is a horizontal asymptote for f of x if the limit as x goes to either plus or minus infinity of f of x is equal to L. Okay. Can we think of a nice example? How about 1 over x? Right, because as x gets very, very large, like 10, 100, let me go ahead and write it. If x is 10, 100, 1000, what do your y's do? 1 over 10, 1 over 100, 1 over 1000, right? These are going to 0. So we would say that x equals 0 is a horizontal asymptote for 1 over x. Oops, I'm sorry, y equals 0. It's a horizontal line. And so the graph looks like that. And so we have a vertical asymptote and a horizontal asymptote. Good. All right. I'm out of time for that. So in our last example, we'll just explore, or we'll summarize our template examples that we've seen today. And then we'll also do a couple of exercises from the text.